Good morning. Let's see what's happening here. Agora vai. Eles estão vendo essa. Good morning. This presentation is about one complete solution using MikroTik for internet service provider. VIPnet is a telecommunications operator in Brazil who uses only MikroTik in all of his network. I will introduce and show how we implement a border, backbone, access, and CPE with MikroTik, IPv6, IPv4, CGNAT, and QoS rules and firewall. This presentation is a tutorial on how VIPnet implements and completes an extremely functional solution with MikroTik. My name is Flávio Camacho. I am an engineer with master degree in telecommunication engineering. I do a lot of presentations and a lot of moons for more than 10 years. I have all of the certifications of MikroTik, and I am a trainer. Let me see the MikroTik technologies. What's the importance of MikroTik for an internet provider? It was used for user authentication, bandwidth control over these users, network routing, OSPF and BGP, customer management, service quality, monitoring, and backbone, access network, and distribution network. To start an internet service provider, you need internet, you need something in the middle before your customers. MikroTik do all of the things between the internet and the customers. When you receive a link, you need a tool to share this link and to configure this link. You need BGP and routing. MikroTik provides this implementation. When you implement security against external and attacks from hackers and from your own customers, you need a firewall in your internet service provider. MikroTik has this function. You have to authenticate users and block defaulters. PPPoE, hotspot, MikroTik do it. You need to control the band and the plans of each client. QoS, MikroTik. Server for centralized authentication, radio server. MikroTik has in user manager. Internal network routing, OSPF, MikroTik. Control of quality of service, MikroTik. Monitoring devices, manager, MikroTik, the dude. Network interfaces, fiber, Ethernet, wireless, everything. Build a network to take the internet to the customers. Radios, antennas, fiber converters, switches. MikroTik has all on a unique and extremely versatile platform. Nothing from multiple vendors with different solutions that are difficult to manage and integrate. Let me see the VIPnet network design. We have 4 levels, network levels in VIPnet. The first level was the border, where we use BGP, NAT, log, firewall, QoS, and QoS. And the equipment was the CCR routers and servers. We have the second level, who was the backbone, where we have only routing and QoS. For backbone, we use fibers, point-to-point, and radios. We have the network level access, where we use POS servers, firewall, QoS, and QE. For that, we use fiber to the home, router boards, and ZPs, and CPS in the clients, where the function was PPU clients, Wi-Fi, DHCP, Slack, and the equipment was the smaller and the cheapest one, Hyperlights, SGT, or anything like this. We have the internet and the border of VIPNet network, where we have BGP equipment, servers of files, web servers, database servers, CGNAT servers, and firewall using CCRs. The next level was the backbone, where we have a POP, point of presence. It can be a tower or not. And these towers, these POPs, was connected by radio to other POPs to leave the internet to the other places, or connected by fiber. We have these two kinds of connections, wireless and fiber. And one POP can have wireless and fiber at the same time. Or we have POPs who receives wireless from one POP and fiber to another POP. In this case, we have a ring. This ring gives the company a lot of good work because we make resilient to fail. And other POPs can receive other links, wireless or fiber. And with this, we do a backbone, a network connecting different points of presence with fiber or wireless to has a access network. In the access network, we have different access. Wireless, where we can put an access point, and via wireless has a CPE with a client. We have clients with wireless. We have clients with fiber, and clients with Ethernet connection. This here was a map from the year 2017 in Rio de Janeiro. Each point was a tower or a point of presence of the company in this year. This city was Rio de Janeiro. This state was Rio de Janeiro. VIPNet in 2009 had 34 active network devices. 4 years later, we have 194. And in this year of this photo, we have 1,199 different active network devices. In this year, 118 POPs, and we give service of internet for 17 cities. The internet was an excellent product to sell. Everybody needs internet, and day by day, year by year, more people will need more and more. Because of that, we grow too much. And we start to use MikroTik in 2007. In the border of the network of VIPNet, we have the internet, but we don't have only one internet service. We have more than one. We have 2 different internet links who was connected to suites, to 2 different suites, and these suites was connected to different BGP border routers for redundancy. The firewall was the same thing. He was connected to a suite where he can open in all the links and all BGP servers, and CGNAT was the same thing. This is how we implement our border for maximum resilient resistance. This is the switch we use in the border. No, this is the routers you use in the border. The routers was used to BGP, firewall, and CGNAT. But each router only one service, not all service in the router. This is the switch we use in the now. And now the VIPNet backbone. First, you have a link. Now you have a border or a data center where you receive this link and administrate this link. But for an internet service provider, you need to go with this link to the home of your clients. And for that, you need to do a backbone. We have a backbone with a lot of different technologies. One is radio. We have a backbone radio. What's good in backbone radio? He has a good transport capacity, very accessible prices, cheaper than fiber. It has OSPF routing in these radios of MikroTik, and it is quick to install. To put a link of 500 meters, 2 kilometers, 10 kilometers, it was easy. One point, another point, 2 radios, in a few minutes you can do it. And you can go to big distances using these equipments. It was the equipment we use, the sleeve and the radio. This radio from MikroTik can give you up to 1.3 gigabits per second. It was a lot of bands. Depending on how many users, customers you have, it was much more than the necessary. This is an example in Gambia, a country in Africa, where we do a link from 75 kilometers and near to 1 gigabit of band with less than $800. This is the designed band. The equipment was the metal, MikroTik. This is the antenna where we see some slides ago. The distance, 75 kilometers, reliable, and 7 meters was the first Fresnel zone. You need one tower with only 7 meters, not a giant tower to put these antennas. This is the design of the link. It was near to the Gambia's river, and with an equipment extremely cheaper. When you have an internet service provider, it was very important, go to far and far and far to take more and more clients. And radio was excellent choice to use. One radio point-to-point for Ginadis, for an example, it was 14 kilometers with near to 1 gigabit of bandwidth, or with 45 kilometers with 300 meters. Everybody talks about fiber. Yes, fiber was the future. But it wasn't interesting. Forget the radio. We start with the radios. We start with wireless internet service provider. We go to the fiber, yes, but we understand fiber was the best, but we have a big space to work with wireless too. And these radios we are looking was from backbone of the network. And this equipment only $175 to do a link of 45 kilometers. It was nothing, it was cheaper than this. And this equipment used a licensed band, 6 gigahertz of band. No problems with interference. Another equipment of MikroTik used in backbone, nearly to $200 and 2 gigabytes. VIPNet has backbone in wireless and a backbone in fiber. In fiber, we do our backbone. Fiber is the future, has no escape. But fiber, no interference, high transport capacity, more than 1 gigabit, only fiber to work very well. but high costs of deployment. It wasn't cheaper fiber. And the maintenance was the cost of maintenance was high because you need a machine to work with fiber, to splitters, and lots of other equipments. In backbone, we use only point-to-point connections. And for this SFP, for an example, gives us 8 kilometers of range. You can have a point of presence in one point, only one fiber, and 8 kilometers more, you have another point of your network. Or with this one here, with 10 gigabytes of network. You have a backbone with 10 gigabytes. With this other, we use these two kinds of SFP. In the backbone, we use the fiber switch to receive. Each POP has a fiber switch connected to one other POP or to the border. This switch has 16 SFP. You can put 16 different POPs connected with this one here. And your network grows a lot. This is an example. You have two switches, one fiber connecting two switches, two SFPs, and with only two SFPs, two switches and a fiber, not a lot of money, you can go 8 kilometers with 1.25 gigabytes. The fiber cable has a lot of fibers, not only one. We are using only one fiber of the cable in this backbone. But the network grows, more clients, more demand, more bands. What we do? We are using only one fiber. With another fiber and another pair of SFPs, you can go to 2.5 gigabytes. Extremely simple, few minutes to install and to grow the network. With one cable like this, with 24 fibers, you can go to 30 gigabytes of backbone transport. And if you use this one, each one gives you 10 gigabytes of bandwidth. With 24, more than the necessary now. The VIPNet backbone was basically radius point-to-point and fiber point-to-point using SFP and switches. We have the network of access, the access network. The access network, we have 5 different scenarios. We have residential wireless client. We have Ethernet resident client. We have resident fiber client. We have corporate fiber client and corporate radio client. For each scenario, we use different equipments, different technologies to give the service who was necessary. In the first scenarios, where we have the residential wireless client, we have a customer. In this customer houses or company, we install an antenna, a CPE, where we have a PPOE client and NV2. It was very important to stability of their network, use only one equipment or all equipment compatible with the same technology. The best one now is NV2. And we have an AP, an access point, in the tower, in a POP. This AP was a PPOE server, QoS, routing OSPF, firewall, QE, and NV2. This is the scenario of wireless connection residential. This AP was connected to the backbone, and the backbone connected to internet. This is the access network for clients wireless. This is the equipment, more interesting, more well used. an AP from MikroTik. You have two different kinds with 50 smaller or more dBs, depending on the plan, the access area you are working. We have these two equipments. And this here was an example of point to multi-point wireless. With a cheaper XST, we can go with 2 kilometers and give near to 1 gigabit. It was much more than the necessary. With a bigger distance, 8 kilometers, 300 megabits. With equipment with better antenna, like in Dina dish, we can go far. 8 kilometers with 800 megabits, or up to 20 kilometers with 300 megabits. Lots of clients of wireless we have using this technology. The other kinds of scenario we have was the residential clients using access network Ethernet. We have a customer. In the house of the customer, we put a CPE, Ethernet CPE, like Haplight. This Haplight does a PPOS client, and it was a wireless AP for the client, only for the client. It was connected by Ethernet network cable to a power box. This power box do a PPOS server, firewall, QoS, routing OSPF, Kiwi, and voltage monitor. This is the photo of the power box. And the power box was connected to VIPNet backbone, who was connected to internet. Let me see. This is the power box. In the power box, first Ethernet 1, we come with power in to energize this equipment. And in Ether 5, with power off, we come out with energy to another power box, located 19 meters to the other. In the first one, we come with energy, and in the Ether 5, we come with power out, PPOA out, more 90 meters, another one. PPOA in, PPOA out. And with this, we go moving, lots of kilometers. These 3 ports here was used for clients. I can have 3 clients at each 90 meters. And in the other, I have more and more. And you go moving and put more and more clients. If you have more than 3 clients in one space, you can put another power box. You use the Ether 4 to energize a second power box. You will have 2 clients in the first power box and 4 clients in the second power box at the same point. This is the line in where the energy comes, the power off to the other power box, and the clients. And this is a photo of how it works. Each one of these was a power box. One power box, cable to this house, another cable, Ethernet cable, power box, Ethernet cable, power box, one house, cross the street, another power box, and moving, and you could go to all of a city, lots of, your imagine was more important. In this case here, we see 2 houses at the same power box. We can have up to 3 without a second power box. And in one point, you put one like this, where you put the energy. The energy, your batteries, your no brakes, UPSs, to give energy to all of this network. This is extremely cheaper. If you would like to start a network, nothing was cheaper than this. And we use PowerBox, but you can use a simple switch. It will be cheaper than using PowerBox. You lost management, but you reduce your cost. The third scenario was residential fiber. In residential fiber, we have a customer, ONU in the customer, connected to a OLT, who was connected to a router board who does the PPOE server. Firewall, QoS, routing, QE, and go to the backbone. The connection was from one fiber. In connection from fiber, you can use this equipment, another power box, but not a power box, with a fiber in. You have a building, three apartments in the building, not necessary lots of NU. We use only one and pass Ethernet cables between the clients in the same place, in the same building, in the same apartment, different apartments. More clients with only one fiber and only one SFP. And we have another scenario with corporate clients. It was the most important clients who pays more and needs a different kind of service. These clients has a dedicated service. We have only a CPE customer in the customer who does PPOE, firewall, QoS, and others, and one dedicated fiber directly from the customer to my switch in the pulp. Clients use fiber to the home. One fiber, lots of splits to attend the clients. The corporate clients, no. They use only one fiber dedicated, connected directly to the switch in the POP. The switch was connected to the router, who was the concentrator, where the services work, and backbone, connection to backbone. The last scenarios was the clients with corporate radios. Oh, fiber was very interesting, but one client who needs internet 100% of the time needs more than one internet link and has two different internet links, all fiber. If one car in front of the building of your client shot the fiber, all fibers will be destroyed at the same time. The more interesting scenario was if you have a link in fiber and a backup link with another equipment, with radio was excellent for the second line. Better than two fibers or one fiber and one Ethernet link, for an example, because these two links has the same risk to stop. In front of your house was the point of fail, was the two different fibers to the same point. Oh, one fiber was to the left and one from the right. Okay, but in this point, these two fibers was in the same point. And if this point goes down, your internet fails. We have a lot of space in Brazil, and I imagine in all of the world, to the links in radio, corporate links dedicated. And this is the scenario we would have. The customer has a wireless CPE who was configured as a bridge, point to point, not point to multi-point. And in the tower, in the POP, we have a second who was dedicated only for this client. With two antennas, two directional antennas, you have a good signal, the best signal, because one was directly connected to the other, to only one. And you have a good service. In the wireless, we have the other service, and the POP connected to backbone. This is the corporate radios clients, who pays a lot for this kind of service. The VIPNet has a distribution of VPAs, we use the RFC to distribute. The first, we have the first part used for customers. Each concentrator receives one network like this, who can get up to 1,000 clients, and can be summarized easily by OSPF. Example, concentrator 1. This network starts, finish, and one part of the network we use only for address the networks and the routers. Okay. Each public IP has 1,000 ports associated with the IP of the clients. This association is fixed, so it's easy to log and locate the client who has a problem with the police or something like this. Public IP. I use it for an example, 192.0.2.1. We'll use the first 1,000 ports. The second IP, the other 1,000 ports associated to one of the IPs of CGNAT. Distribution of IPs, I can go to the first up to the 64, because it was only 65,000 ports in each IP, I can use only 64 IPs. Recommendation of RFC, I use for all of the people, residential and business, the first option. And this is how we can use to do easy to understand the IP and the clients. The first octet was 100. The second it can be from 64 to 95, 31 possibilities. The second one, 0 to 99, 100 possibilities. And the last one, 1 to 61, 65, 64. 64 possibilities. All with this sequence, we can have nearly 200 million, 200,000 users. Sorry for the English. And we associate, all of our clients have IPv6 and IPv4. All of the network has IPv6, and all clients receive. If the client will use the IPv6 or no, it was a problem of the clients. But all of the network uses, and all the clients receives an IPv6. And the IPv6 was like this. To be easy to understand, if I know the IPv4 of the clients, I easily understand the IPv6 because they was very similar. Example, if the IPv4 of the client was 164.0.1, the IPv6 was 64.0.0.1 with the mask of the client. CPE customer premises. We see the data center, the backbone, access, and the last one was the CPE of the clients. The CPE is important in each client for management, to isolate the clients from the rest of the network, to implement the bandwidth and firewall controls directly in client's home. With this, your backbone stays more clear, because all of the hard work was done in your clients. You open the firewall in your clients. The bandwidth was controlled in your clients. Your client goes to the backbone only with the bands he has. Most people control the bands only in the end of the backbone, nearly to internet. But when you do it, the clients can use all of your network with 100% of bands up to the border of your network. Only one client can go down your network if he has a virus or a bad idea. We implement a CPE because of that, to start the fire in the client's house. And you can give a wireless to add value. We mark the packets of the clients in the clients one with the QoS. And this customer premises CPS was very cheaper nowadays. And this CPS gives to your clients graphical service, because MikroTik has graphics. He can see the bandwidth he was using, time he accessed the equipment. Each residential client has a CPA client, light. The CPA works as a PPOE client to authenticate the user. The network between the access network haven't any IP. Works only in PPPoE, without IP in interfaces. The one interface of your client has only PPPoE clients installed, and in access point, or the first router, it was only PPPoE server active, no IPs active. And the CPA has another user facility, was the DHCP server. For the client, we give the DHCP automatically, not necessary to configure manually. We do a personalization of the CPA for the client can access and see only the options he needs to configure, like the Wi-Fi network, some firewall networks options was disponible for the clients. The client can change the DHCP IPs for his network intern without call the support of the company. We have a wireless pre-configured to easy helps the client. And we implement the Slack in the router to give the IP to the clients, IPv6 to the client. Então, DHCP, to be easier, each IP in the router of the client was associated with one port, because all clients tell, oh, open port 80, open port 22, open. The ports was open and redirected directly to these IPs. The client only needs to put one of these IPs in the network device who needs one of these ports. For the other equipment, the DHCP gives the IP from 200 to 253. And the other IPs was associated to designated ports. And the gateway was the 24. This is the equipment used for this. One equipment with less than $20. All the features, all the help you give, it was very cheap to put one in each client. Very, very interesting. It was used in home Ethernet clients. In clients who was used fiber, we use this other one. We can use the X. The X was better, but more expensive. Or the GS, who was very cheaper, but it was only a switch. Wireless client use these equipments. Different equipments for different distances. If the client was less than 8 kilometers, we can use a new XXT. If he was more than 8, we can use LHG, and more distant, more equipment, different equipment antennas for different distances. The GPON, MikroTik GPON, and CGNAT. We have the network of the customers, who was RFC 1918, who was private IP 192.88.0, was the MikroTik padrão, the full. In the customer's PC, we have the CPA who gives this IP for the DHCP for the clients, and has a carrier network, to the backbone, to transport this. In the border, we have a CGNAT router who changes it for a public IP and goes to the internet. Internet, BGP, we have one CGNAT for each 4,000 clients. CGNAT was very expensive in networking processor for the router. We use lots of different SysNATs, one for each block of network, of clients, like this. The firewall, we have two firewalls in the network of VPNet. One firewall connected to the customers, to control the customers, and another firewall with the border control the internet. In the middle, in our backbone, not firewall, not necessary, because all traffic was organized, was filtered, and was controlled. It was good because all of your routers in the network works better, because all of the trash you take out before goes to the backbone. The firewall, the first firewall works or in the access point or in the power box. And the second firewall works in a CCR near to the border. The firewall in the first connected direct to the client wasn't necessary a big equipment, because you have 1, 2 clients in this equipment. You have lots of network firewall rules, and it works very well. In the network, in the border of the network, you need an equipment very bigger, very more expensive, and more efficient because the traffic was bigger. In this point, we use a CCR. It was only to remember, it was a good place to everybody do. We do the anti-spoof network control. We drop all packets if it comes from the first firewall and the IP wasn't one of the delegated to this client. If any package comes to the first firewall and the IP wasn't from this network, it was dropped. The same thing in the border. If any packet tries to go out of my network and it wasn't from my network, it was dropped. The bogons was filtered in the firewall 2, coming in and come out. And each router only accepts connections from the other routers or from my management IP. I have a group of employers in a network, a specific network, used to access and manage the equipment. My customers with his IP was impossible to access any equipment in all of the network. Only the management IP or the other routers. It was another filter input. And remember, all of these network filters can be twice. One in IPv4 firewall, and everything one more time in IPv6 firewall. Because the network has this IP in all equipments, you need to do 2 different firewalls configuration. QoS. In VPNet, we have 5 different classes of service. The first class of service was monitoring. At this class, we have the network of monitoring and the routers. This class has the bigger priority. The second class was the VoIP. At this class, we have the VoIP servers. The third class was VIP. At this class, we have the clients with full guarantee of bands and the more important clients. We have one class named business with companies and residential. Residential was the customers with the low ticket, small priority. If you lost, no problem. No impact in your country, in your company. This is the classes. The first class, monitoring, has a max limit, small, but the limited was the same as the small limit. And the priority was 2. This package was marked with a type of service, 2, in the package. The second one was the class VoIP. It was, the max limit was medium, not too big. But the there was the same as limited for 100% of guarantee. And priority 3. And this package was marked as a type of service 3. The other class, VIP, is variable because I have clients with same 100 megabits, 20 megabits, different bandwidth. So the max limit was variable. But the limited was the same as the max limit. 100% will be guaranteed. It was priority 5 and package type of service 5. The business client has max limits, different maximum limit because we have a lot of plans, different plans. But 50% of this maximum limit was guarantee. And the residential, 25%. If has bands. Why I use type of service? Because type of service was one flag into the IP package. The other queue is, the other quality of service works only into the router. But I need to do the quality of service from one point to the network to the other point to the network to guarantee all of the traffic. Because of that, I need to mark the packet with one mark who can go out of the router and continues for all of the network. And type of service was used exactly because of that. It wasn't, each company can do like he would like. Here is the customer, and his package has one mark who can go to all of my network, all of my routers, and we know this package comes from this kind of service, this kind of client, of this point. And I have a VoIP server. I give to my clients not only internet, but I give telephone too. It gives, you have a big network. If your client can pay you for network, internet, and for telephone, it was good. More money and nothing more to do. But VoIP too works very well. I use the QoS for my server. It works only for my server, not for any VoIP in the network. My VoIP works well because I mark based. I use the mark based on my VoIP server's IP. If the package was coming and the source address was my VoIP server, he will go in the QoS tunnel. If the customers goes to my VoIP server, the destination address is my VoIP server, this package will go in the managed or VoIP. But any other VoIP will not get QoS. Works normally. Customer goes with his source address, goes to the router marks the package, and gives the package to the backbone. Internet to customers. The packet comes to internet. And the first router marks the package before gives to the backbone. The client has QoS from client to internet and internet to client. In my network, all of the clients has guarantee of service. Because of that, I mark the packets in the border and in the access point. For this, we use PPWA with address list. This is an example of the VoIP server type of services equipment. Another example of the configuration of VoIP server package. This is only a tutorial for do the quality of service. Remember, in IPv6, we need to do all of the same network quality of service, because do quality of service for IPv6 and for IPv6, IPv4 and IPv6. And the VPNet company started its operation in 2004. In 2007, we started using MikroTik. In 2017, we have 4,000 customers using only MikroTik radios and routers. We are the success story, and MikroTik is part of that. Thank you.